Now this is the form of Fubini's theorem for a bread pan that has a rectangular base. So either way, we're talking about x between two constants and y between two constants. But there's no reason why bread pans have to have rectangular bases, right? You could have all sorts of interesting shapes for your bread pan. The principle should still work. Let's look at an example. We have some surface here, and we want to find the volume between this surface and the region of the xy plane that's given by these two inequalities. This time x is between two constants, but y is between two functions that depend on x. So we have a region here. I went ahead and graphed it in Maple so that you could see it. So this is looking down on the bread pan, right? If we tip it up, you can see we have this surface, and we're just trying to find the volume between the surface that we have and the base. So now the way that this is given to us, what we'll want to do, since let's see, here's our graph here, since x is always between these two constants and we want our answer to not have any variables in it, then the variable that goes between two constants will go on the outside. And then if we slice in constant x, you can see that along that slice, then the y value goes from 0 until it hits this curve, which is the square root of x. So our y values are going from 0 to the square root of x, and we just take our function e to the y by root x, and we integrate that dy. That is going to find the area of the face of one of our slices, right? And then we'll take the area of that face times its thickness dx, and we'll sum up all the slices from 1 to 4. That's how we can compute our integral by doing two integrals from calculus 1. So first we take an antiderivative with respect to y. That means we're assuming square root of x is held constant. So we do that antiderivative. And see, we're going to need to put a little square root x here so that when we take the derivative, we get e to the y by root x times the derivative of this with respect to y would throw out a 1 over root x, and this is ready to catch that. We'll just evaluate this between 0 and root x. Now notice the integral is with respect to y, so the variable that I'm replacing is the y variable here. So if I replace the y with root x, I get root x over root x, that's e to the 1 times root x, so I get e times root x, minus, if I plug in 0, e to the 0 over root x is e to the 0, and e to the 0 is 1, so I get minus root x. Okay, or if you like, you could factor out the root x. This is e minus 1 times the square root of x. Now that we know the answer to the inside integral, we'll just put that in here and complete the integration. We're going to integrate from 1 to 4. This function, basically the square root of x dx, since e minus 1 is a constant. Think of that as x to the 1/2, then the antiderivative would be x to the 3/2 with a 2/3 in front. Don't forget our e minus 1, that's also a constant there. And evaluate that between 1 and 4. So we have 2/3 e minus 1 times, let's see, if we plug in 4 here, the square root of 4 is 2, and 2 cubed is 8. Minus, if we plug in 1, the square root of 1 is 1, and 1 cubed is 1, so 8 minus 1. So altogether we have 8 minus 1 times 2/3. 8 minus 1 is 7, times 2 would be 14/3 times e minus 1, and that will be the volume. So the fact that we can do that is guaranteed to us by Fubini's theorem. So suppose we have a function that's continuous on some region. Fubini's theorem says, well, if you can define the region by using two inequalities where x is between two constants and y is between two functions of x, and as long as those boundaries are nice and continuous as functions of x, then you can go ahead and find the area of the face of one slice, multiply by its thickness, and then sum up all of those slices. If you have it the other way, so that y is between two constants, it's basically the same deal. As long as h1 and h2 are nice and continuous, then you know you can just sum up the volume of a single slice, sum up all of those slices, and you'll get the volume of the entire loaf of bread.